Here's the review key for the Unit 2 study guide. We start off with inequalities. So we have to solve these, then we have to graph them, and then we have to write the answer in interval notation. So for the first one, we're going to divide both sides by -5. Alright, because we are dividing by a negative number, the inequality sign will flip to the other way, and we'll get x is greater than 2. Alright, on the other side, we're going to subtract by 6 to get the x by itself, which gives you -3, and then x. I'm going to flip this inequality around because I like my x's on the left-hand side so I can follow the arrows when I'm graphing these. It says the same thing, it's just flipped around. Notice the inequality sign is still pointed at the x, it's just backwards. Okay. So now we go to graph. So we start off at 2. With the parentheses going to the right. We have a bracket at -3 going to the left. Now this is an AND question, which means these two graphs have to overlap to answer the question correctly, and since they don't, this is a no solution. Okay, they do not overlap, and it's an AND, so it's no solution. If this had been an OR question, we would have been fine. All right, moving on to number 2. Again, we're going to solve the inequalities, graph it, and find the interval notation. So we're going to subtract by 1. So 3x greater than or equal to 1. Divide both sides by 3. So x is greater than or equal to 1/3. The next one, I'm going to add 3 to both sides. So -x is greater than or equal to 5. I'm going to divide both sides by -1 to get the x by itself. When I do that, because I divided by a negative number, the inequality sign will flip and get -5. I'm graphing this, so I'm going to have -5 here with a bracket going to the left. I'm going to have 1/3 here with a bracket going to the right. Again, this is an AND question, and since they do not overlap, again, this is a no solution. Okay. All right, number 3. Now we have a compound inequality. This is one where there are x's in multiple locations, so we're going to have to divide this into 2 separate pieces. We're going to have this as an equation. And this as an equation. So we're going to use the middle part twice, the entire middle part, not just part of it. So I'm going to have x plus 2 is less than or equal to 2x minus 3. And write the other part down too. 2x minus 3 is less than or equal to x plus 8. So I'm going to solve both these equations. I'm going to start by subtracting 2x and subtracting 2. So that one cancels there, and this one cancels there. So I'm going to have -x is less than or equal to -5. Divide by -1 on both sides to get the x by itself. And x, the inequality sign will flip around because I'm dividing by a negative number, is greater than or equal to 5. On the other part of this equation, or the inequality rather, I'm going to subtract by x and add 3. So I'm going to have x is less than or equal to, what is that, 11. Okay, now because this is a compound inequality, this is an AND question. So I'm going to graph it next. So I have 5 with a bracket going to the right. I have 11, the bracket going to the left, and they're going towards each other. So where they overlap, since this is an AND, that's what I want. So I'm going to have a bracket with 5, 11 with a bracket. And those are answers. Okay. Don't forget to put the interval notations. Number 4. This we have an absolute value inequality. To start this off, I need to get the absolute value brackets isolated, so by themselves, which means I have to subtract 2 as the very first thing I do. So I have the absolute value of 3x plus 2 is greater than or equal to 8. Okay, now a couple things on this problem. I'm looking at my inequality sign. This, oh, let's go back and I'm going to make it yellow. This, okay, it is a great or, so this is an or question. Okay, and now that I have my inequality, or sorry, my absolute value brackets isolated, I can make my two separate equations for an absolute value inequality. So 3x plus 2, it's an ugly plus, there we go, that's a little bit better. 8, and then for the other one, I'm going to have 3x plus 2, I'm going to switch the inequality sign around, I'm going to flip it, and it's going to equal negative 8. Now I can solve. I'm going to subtract 2 from both sides to get 6. 3x. Divide both sides by 3. So x is greater than or equal to 2. The other side I'm going to subtract 2 again. So I have 3x is less than or equal to negative 10. Divide by 3. And x is less than or equal to negative 10 over 3. Now I go to graph this. I have negative 10 over 3. With a bracket going to the left, I have positive 2, the bracket going to the right, and that's good because I have an or. Remember, this is an or question, so they don't have to overlap. So I write my interval notation as negative infinity to negative 10 over 3 with a bracket, my break 2 to positive infinity. Now again, remember that infinities, whether negative or positive, cannot have a bracket on them because they cannot be included in your answer. You don't know what they are. It is what it is. All right. Now we have an or. Okay. All right, so we're going to subtract 4 from both sides to solve for x. So I have 3x is greater than or equal to 2. Divide both sides by 3. X is greater than or equal to 2/3. Other side, I'm going to subtract 3. I have 4x is greater than or equal to, what's that, 8? Oops, forgot the x next to my 4. There we go. Divide both sides by 4. And x will be greater than or equal to 2. All right. All right, so graph this. We have 2/3 with a bracket going to the right. We have 2 with a bracket going to the right. Now this may seem a little bit weird. That's okay. Again, this is an or question, so they do not have to overlap to make the answer correct. So we can start from way back here at the 2/3. We're going to use that as our interval notation. Okay, and it goes towards infinity. This would be your answer for your interval notation. Okay, it doesn't make a difference where they overlap. If this was an and question, you'd start at 2 and go to the right, but it's an or question, so we can have 2/3 or 2 being a good answer, and we're going to go from the 2/3 because it's an or. All right, number 6. This is a simple compound inequality. We don't have to make two separate equations. You can if you want, but it's kind of useless. We're going to solve for the 1x that we have by adding 9 on all 3 parts of our problem. So 9 plus 5 is going to be 14. And 12 plus 9 is going to be 21. Okay, so I'm going to graph this. Okay, I have 21 over here going with a bracket to the left. And I have 14 over here with a bracket going to the right. Now, because it's a compound inequality, this is an and question. And that's good because that's where they're going to overlap between those two things. So my interval notation will be 14 to 21 with brackets on both numbers. Number 7 is another compound. So we're going to make our 2 equations with the left and the middle. And the middle and the right. Those are our 2 pieces. So our first equation is 3x, sorry, not x, 3 plus 5x is less than or equal to 4x minus 2. Then 4x minus 2 gets used again with the 3 minus x. I keep putting them on and put the x in my 3's. All right, so we're going to solve these two separately. So the first one, I'm going to subtract 4x. And I'm going to subtract 3. So 5 minus 4 is going to be 1x is less than or equal to negative 5. On my other problem, I'm going to add x to the left and add 2 to the right. So we get 5x is less than or equal to 5. Divide both sides by 5, and x will be less than or equal to 1. All right, again, this is a compound inequality, so it's an and question, or an and inequality. So if I graph this, I'll have negative 5 here, the bracket going to the left, a positive 1 there with a bracket going to the left. Okay, but this is an and question, so we want to know where they're going to overlap. Well, they're only going to overlap when the 1 graph goes over the 5. So what we're going to do is we're going to erase this 1 because it's not part of our answer really. We're just going to use the 5. And after the 5, where the 2 lines will be overlapping is where our answer is going to be. So we're going to use that as our interval notation. So we have negative infinity to negative 5 with a bracket. And that is the answer. Okay. Again, they have to overlap as it's an and question. And between 1 and negative 5, they don't overlap. There's just that one graph. They only start overlapping when the 1 graph meets the negative 5 graph. Number 8, absolute value inequality. So this one's already isolated, so the absolute value is already by itself, so we can just make our 2 inequality equations. We have 2x minus 3 is less than 7, and 2x minus 3 is greater than negative 7. So I add 3 to both sides. So 2x is less than 10, divide by 2, x is less than 5. On the other side, I add 3. 2x is greater than negative 4. Divide both sides by 2. X is greater than negative 2. All right, now if we look at our inequality sign here, make that yellow again. Okay, this is a less than, so it's an and question. So we have our graph. This is negative 2 with a parentheses and positive 5 with a parentheses. They're going towards each other, and that's good because they're overlapping for an and. So my interval notation is negative 2, comma 5 with parentheses on both. Okay, moving on. We're going to solve some quadratics. You can use any method you want. I'm going to show you the method that I would recommend to use for each one of these. I've never done these, well, I haven't done these in over a year, so I'm just going to guess what I think is correct based on my experience. So I'm going to start with the bottoms up method for number 9. I'm going to do 3 times negative 10, it gives me negative 30. I'm going to find 2 numbers that multiply to be negative 30 and add it to be positive 4. So it's 3 and 10, that wouldn't work. 2 and 15 wouldn't work. 5 and 6 wouldn't work. Okay, so I don't think there is one. So we're going to switch gears. We're going to do the quadratic formula. A quadratic formula, as far as I know, will not be in, it's not going to be included. It is not going to be given to you on the test. You're going to have to remember it. I'll put it up here on the top as a reminder. It's negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So in this problem, 3 is your a, 4 is your b, negative 10 is your c. So I'm going to put negative 4 plus or minus the square root of 4 squared, put that in parentheses just in case, minus 4 times 3 times negative 10. All divided by 2 times a, which is 3. So what I'm going to do is I'm going to multiply the stuff inside the square root sign. So I have 4 squared, which is 16, minus 4 times 3 times negative 10 gives you 136. 4 plus or minus the square root of 136, all divided by 6. And that's as far as I'm going to take it, and we're good. Now I know this wasn't factorable now that I've done this problem because the square root of 136 is not a perfect square, thus there's nothing you can do with this. Okay? All right. Number 10. I'm going to try factoring this one. 3 times negative 2 is negative 6. 2 factors of negative 6 that add up to be negative 1 is going to be negative 3 and positive 2. I'm going to divide both these by the first term, which is the 3. So I'm going to get negative 1 over 1 and 2 over 3. Put an x there. So I have x minus 1 as my first factor and 3x plus 2 as my second. And take both of those, set them equal to 0, so I can solve for x. So the first one, x will equal 1. All right. And then the second one, I'm going to subtract 2, divide by 3, so x will equal negative 2/3. All right. Number 11. I think this is probably a factoring one again. I'm going to take a guess. Probably not, actually. It's probably another solving using the quadratic formula. So I'm going to put in the quadratic formula since the b value, since this is a, b, and c, the b value is already negative. So in the formula, it's negative b, which means that turns into a positive. Plus or minus the square root of negative 4 squared. Notice I put that in parentheses because when you square it, and it's a negative number, you should get positive 16. If you don't put it in parentheses in your calculator, you'll get a negative, and then you'll get the problem wrong. Minus 4 times 1. Oh, this might have been factorable. It was. All right, we're going to back up. All right, I realize it's factorable because what was going to be in there was going to be a perfect square. Actually, it's going to be 0. So let's back up. Back it up. Okay. 4 times 1 is 4. The two numbers that multiply to be positive 4 but add to be negative 4 are negative 2 and negative 2. I put 4 on the bottom as my denominator because that's this first term. I'm going to get negative 1/2 and negative 1/2. Put x and x. So I have 2x minus 1 as both factors. Okay, so I have to only to solve this once because they're going to be the same number. So I set it equal to 0 and solve for x, which is 1 over 2. Okay. What this means for a quadratic, just in general terms, is that when if you were to graph this equation, it would hit the x-axis at the very vertex of the parabola, right there. That's why it only has one x-intercept, because the vertex is the x-intercept. All right. You don't really need to know that for the test, but I just wanted to show you. All right, next one, we're going to use solving using square roots. So what we're going to do first is we're going to add 36. Because we want to get the x squared term by itself. So I have 3x squared equals 36. I got to divide both sides by 3. I have to get the x squared term by itself. A lot of people are square rooting the 3x squared. Don't do that. So x squared is equal to 36 divided by 3 is 12. Square root of 12 both sides. So the square and square root cancel out. You get x is equal to, and here's where people are going to get this wrong. It should be plus or minus the square root of 12. I'm not asking you to reduce the square root of 12. I'm just asking you to put the plus or minus. And that would be your answer. All right. Solve each of the following. We have our fractional or rational equations. Okay. In this case, what we got to do for each of these is we have to factor the top and the bottom, the numerator and denominator. And whatever's left over after we cancel things out of their common, we're going to solve for the numerator. So the first one, I'm going to have x plus 4 and x minus 1 as our factors. The bottom, two numbers that multiply to be negative 12 but add to be positive 4 are x plus 6 and x minus 2. Now you'll notice that nothing cancels, so we're just going to take the numerator values, or factors rather, x plus 4, set it equal to 0, x minus 1, set it equal to 0, and x will equal negative 4 and positive 1. So we're just caring about the numerators, not the denominators. I don't care what the denominators are unless they cancel something. We're just solving for the tops of our fractions. The next one, two numbers that multiply to be negative 10 but add up to be positive 3, x plus 5, x minus 2. Two numbers that multiply to be 15 but add up to be 8, x plus 5, x plus 3. Now here we have x plus 5 and x plus 5. You're going to cancel those two out. And all we care about now is the numerator. X minus 2 is equal to 0. X will equal to 2. Okay, we are trying to avoid what will make the denominator equal 0. And if you solve for the x plus 5, which gives you negative 5, that will make your denominator 0 and thus undefined, which is not good in math. So we only care about what the numerator says. All right. 15. Factoring this, we have x minus 5 and x minus 4, two numbers that multiply to be positive 20 but add up to be negative 9. On the bottom, we have x plus 3 and x minus 1. Again, nothing cancels, so we're going to take our two numerator factors, x minus 5, set them equal to 0. And solve. X will equal 5 and 4. Okay. Solving using square roots. I'm sorry. So these are radical equations, not solving using square roots. That was before in the quadratics. All right. In this case, what we're doing first is we're making sure that our square root signs are the portion of our equation that has a square root on it is isolated. It's by itself. Nothing is being multiplied, divided, added, or subtracted out in the outside of it. In this case, it's not, so we have already isolated it. To get rid of that square root sign, we're going to square both sides of our equation. The squared and square root will go away. I'll have x plus 7 is equal to 2 squared, which is 4. I'm going to subtract 7 on both sides. And I have x is equal to negative 3. Just checking something. Okay. Next, this is not isolated, so I have to add the 4 before I can start squaring anything. So the square root of x minus 3 is equal to positive 3. Now you might have said, well, it equals a negative number, but not after you add the 4. So now we're okay. All right. Square both sides, but now that the square root sign has been isolated, cancel those two things out. X minus 3 is equal to 9. We're going to add 3, and x will be equal to 12. Now notice I did not test these out to make sure they worked. That is because there is no x on the outside of the equation, so I should be fine. Okay, if you want to check them out, we can real quick. We'll go back to 16. Negative 3 plus 7 is 4. The square root of 4 is 2, and that's what it equals, so that one checks out. Here, if I put 12 in, 12 minus 3 is 9. The square root of 9 is 3. 3 minus 4 is negative 1, and that one checks out. All right, same idea. We got to isolate this first. We're going to subtract 5. The square root of 2x minus 3 is equal to 3. I'm going to square both sides. The square and the square root will cancel. Get 2x minus 3 is equal to 9. I'm going to add 3 to both sides. 2x is equal to 12. Divide both sides by 2. X is equal to 6. If we try it out, 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3, and 3 plus 5 is 8. So those all work. All right. Oh, we're getting there. Getting there. Number 19, we have the absolute value equations. Okay, the same idea as the radicals. We have to get the absolute value equations, the absolute value parts of our equation isolated so that there's nothing being multiplied, divided, added, or subtracted to those brackets. So we're going to add 2. So we have 3x plus 4 equals 13. Now I can make my two separate equations. 3x plus 4 is equal to, actually, sorry, that looks like a inequality sign, is equal to 13. 3x plus 4 is equal to negative 13. So the first one I'm subtracting 4. So 3x is equal to 9. Divide both sides by 3, and x will equal 3. On the other side, I'm subtracting 4. 3x will equal negative 17. Divide both sides by 3, and x will equal negative 17 over 3. Now, I know that since there's no x's on the outside of the equation, I don't really have to check. I can if I want to, just to be double check to just be sure, but I know these will both work. There's no x's on the outside of the brackets, which would cause the problems to begin with. Okay, number 20. Now this one does have an x on the outside of the bracket, so I will definitely be testing this one when we get to it. Okay, in this case, nothing's being multiplied, added, subtracted, or divided on the absolute value bracket, so we are ready to make our two separate equations. We have x minus 8 equals x plus 2. Our second one's going to be x minus 8 is equal to negative, and I'm going to put the x plus 2 in parentheses because it has to change both signs, the x's and the 2's. So in the first one, I'm going to subtract x. These two will cancel. That's not good because negative 8 does not equal positive 2, so this doesn't work. So we don't have to worry about that one. The other one, we're going to get x minus 8 equals negative x minus 2. I'm going to add x to both sides. I'm going to add 8 to both sides. All right. So I'm going to get 2x is equal to 6. So divide both sides by 2, and x will equal 3. All right, I have to check this out to make sure it works. I have 3 minus 8 is negative 5. The absolute value of negative 5 is positive 5. And 3 plus 2 is 5. So that does work. Okay, I'm only going to get one answer for that particular question because the other one, it doesn't have one. Okay. All right. Draw a picture and solve the word problems below. You must draw the picture for these problems. If you think you can do it without the picture, that's great. You still need to draw the picture for the test. So whether you want to draw the picture or not, it's required for the problem. Okay, it's part of your power standard. It's power standard 1.1. It's the annotation standard, but it's drawing a picture. The picture has to be good enough that it shows you everything about what we're doing, and I will demonstrate what those look like when we're doing this problem now. A rectangular picture has dimensions of 10 by 20 inches. So we have our picture. It is 10 by 20. The frame around the picture has a uniform width. Uniform width means that this and this value are both x's. Okay, and an area of 400 square inches. So just the frame itself has 400 square inches of area. I don't know how wide the frame is. Well, the first thing we need to do is figure out what the dimensions of the frame are. And because it's uniform width, we have x plus 20 plus x. So it's these three. Give you 2x plus 20. All right, on the other side, we have x. We'll do it in a different color just so you can see it. We have x, this x right there. We have the 10. We have this x right here, which gives you 2x plus 10. Go back to blue. Okay, this is the basic picture you need. You don't need the circles, but you do need to show what the dimensions of the picture frame are. All right, so I've drawn my picture. Now I can make my equation. I have 2x plus 20, and I have 2x plus 10. I'm using this because to find the area of a rectangle, which is base times height. So the base is 2x plus 20, the height is 2x plus 10. That equals the area of the two things that make up this whole picture. We have the picture of the picture of the frame, which is 400. We have the picture of the picture, we have the area of the picture itself, which is 200. I got the 200 by multiplying 20 times 10. So if I multiply the stuff on the left, the 2x plus 20 times the 2x plus 10, I get 4x squared plus 20x plus 40x plus 200 equals 600. If I combine the like terms, I'll get 4x squared plus 60x minus 400 equals 0. Okay, now I have to solve this quadratic. To do that, I'm going to make my life easier by dividing everything by 4. All right, that will allow me to make the numbers much smaller. So if I divide everything by 4, taking out the greatest common factor of 4, I'll be left with x squared plus 15x minus 100 equals 0. Now I got to find two numbers that multiply to be negative 100 but add up to be positive 15. So let's see. 20 times 5 is 100. So if I do positive 20 and negative 5, 20 times negative 5 is negative 100. 20 minus 5 is positive 15. Those are my factors. I set each one equal to 0 and solve for x. I will get x is equal to negative 20 and positive 5. Can't have a negative distance, so my answer is going to be 5. So it is 5 inches wide for the frame. Number 22. Ooh. A rectangle has an area of 120 meters if the length of the rectangle is 8 less than 2 times the width. Find the perimeter of the rectangle. So here's our rectangle. Okay. The length of the rectangle is 8 less than 2 times the width. So the question is, what is the width? Right. If you're trying to find a number for it, don't. It doesn't tell us what the width is. The width is x. We don't know it. Okay, what is the length? It is 8 less than 2 times the width. So 2 times the width and 8 less than that. There's your width. So now we have the dimensions of our rectangle. I almost said triangle. We found the dimensions of our rectangle. If we're finding the area of a rectangle, it's again base times height. So we have x times 2x minus 8. And the area of the rectangle, it tells us, is 120 meters squared. So I'm going to multiply this out. I get 2x squared minus 8x. I'm going to subtract the 120 to bring it to the other side so I can set my equation equal to 0. I now have a quadratic. Much less like the problem before, I'm going to factor out a 2, a greatest common factor of 2, to make my equation much smaller in terms of numbers. So I have x squared minus 4x minus, what's 120 divided by 2? 60. Okay, so now I'm going to figure out two numbers that multiply to be 60 but add up to be negative 4. How about negative 10 and positive 6? Okay. So if I solve both those, x will equal positive 10 and negative 6. The negative 6 doesn't make a sense for a distance. So my width is going to be 10. All right. My length is 2 times 10 minus 8, which is 12. Okay, but I want to find the perimeter of the rectangle. The perimeter of the rectangle, I have to add up all the different sides of a rectangle. 2 of them are 12. 2 of them are 10. So it's 24 plus 20 gives me 44. And that's my answer. So my answer in this case was not what the x equaled. There was a secondary answer. I needed to find the x to find the answer, though. All right. Last two questions. 23. So he has 40 quarts of a 20% acid solution. So here's our first bucket. It's 20%. It's 40 quarts. All right. How much of the solution must be poured off? So we're subtracting. It's still a 20% solution. We don't know how much he's pouring off. And we're replacing it with pure acid. Since it is pure, it must be 100%. Again, we don't know how much we're adding. But when we are done, we're going to get a 60% solution. And then the amount is going to be 40 again, because 40 minus x plus x is 40. So we multiply straight down. 40 times 20 is 800, minus 20x plus 100x equals 240 times 60 is going to be 2400. All right, I combine the like terms, I get 80x equals 2400 minus 800 is 1600. Divide both sides by 80. X will equal 20. Okay, last problem, here we go. Meg has an 80% oil solution, so here we go, 80. And a 50% oil solution. So we're going to add those two things together. How much should be mixed to create 100 cups of a 63% oil solution? So we're going to equal a 63%. All right, now the question becomes, what are the tops? So the end part is going to be 100 cups, okay? The first one, the 80%, we're not sure, so we put an X. Now the second one, we're also not sure, but we can't put the same X because that wouldn't make sense because we're not necessarily adding equal parts of the things to get to 63%. So what we do is we know that we're going to end up with 100, and we know we're adding X. So we're going to actually subtract X from 100 for the 50%. Because if you take 100 and minus X, it leaves you whatever's left over is going to be the 50%. All right, so logically that makes sense. All right, so now we multiply down. So we have 80x plus 5,000 minus 50x equals, 6,300. Okay. So if I combine my like terms, I'm going to get 30x equals 1,300. Divide both sides by 30. And x will equal 43.3. Okay, so that's what x equals. So that's the 80% solution. All right, the other value is going to be 100 minus 43.3, which gives us 56.7 of the 50% solution. So these are your answers. We wanted to know how much of each. Okay, the question was how much of each. So we have the amounts for each, and we are now done. Congratulations. Good luck on the